Okay, guys, so let's talk about the atomic theory. Okay, so that's basically the theory of atoms, how they came to be, that sort of thing, and what they tell us. So the first thing we're going to talk about is the history of the atom. The first guy we want to talk about is John Dalton. Now, John Dalton was one of the first people to think of the idea of the atom, and his theory essentially remains the same today with a few basic changes. The first thing we want to know is that Dalton's atomic theory is called the billiard ball model. Okay, and it had three main things. The first thing is that all matter is made up of atoms. Now, just as a review, we know that matter is anything that has mass and volume. Okay, so that means everything. Everything is made up of these small particles that Dalton called atoms. Atoms are indestructible, meaning you can't destroy them, and they cannot be divided into smaller particles, indivisible, saying the smallest thing you can have is an atom. And the third thing he said was all atoms of one element are exactly alike, but are different from atoms of other elements. This postulate number 3, is why it's called the billiard ball model. If you look at a pool table, okay, these are the pool balls. Now the number 8 is black with a white circle with the black number 8. And an 8 ball looks the same at every pool table. No matter what 8 ball you look at, they all look exactly the same. But an 8 ball looks very different from the number 1 ball. Okay, so they're different from each other because they're different types of balls, but they're all the same if it's that 8 ball. The same way that all carbon atoms look the same, but a carbon atom is different from a nitrogen atom. Then came around JJThompson. Now, JJThompson did a cathode ray tube experiment, and the main thing you need to know about him is that he discovered the electrons. And because we know that matter is neutral, meaning it does not have a charge, we realized it also has to have positively charged particles in there somewhere to balance it out. Neutral means 0, so if we know that we have negative electrons, there has to be something in there that's positive. And so he came up with this idea of the plum pudding model or the chocolate chip cookie model, where he says that the atom is basically this positive space that has little negative components to it. They're like randomly in there. They have no order. It's kind of like raisins or chocolate chips in a cookie, right? You don't know how many you're going to have. They're completely random. They might be all bunched here or all bunched there or spread evenly, but you have electrons and then positive space throughout. And this stayed around for a while until this guy named Ernest Rutherford came along. Now, Ernest Rutherford did what we call the gold foil experiment. And in his gold foil experiment, he discovered the nucleus. And he said that atoms were made up of mostly empty space. The way he figured this out, if we want to dive into his experiment a little further, is with this. Now, this looks very complicated, but essentially what happens is he had a radioactive source like uranium or polonium, something along those lines, and he used it to put a beam of particles through here. Now, what happened was it would hit the gold foil. Now, if JJThompson had been correct, he would have expected all the beams, all the atoms, to bounce off the gold foil and go back. But what happened was some of them went straight through and some of them were deflected at different angles around the gold foil. Okay, essentially here what happens is sometimes the particles would come all the way through, hit the nucleus, and bounce off. Some of them would travel right through empty space and go directly apart. And if they hit the nucleus more directly, they would bounce further back. So essentially, he discovered that atoms had a lot of empty space and that there was this positive center. Because if it was positive and the beam they were shooting was negative, it would kind of bounce off that way. And you can follow the link in the PowerPoint if you would like to watch a video about it. Rutherford, we call him the nuclear model. His atom, if you were to just kind of draw it with your pencil, would kind of look like this, where you have a positive you have a positive nucleus in the center with protons, and then you have your electrons that are kind of floating around here, but the area in between the electrons is now empty. Niels Bohr came around and he said, I don't think electrons just float around. I think electrons are in these orbits, okay? These orbits that are around the nucleus, and he called them energy levels. So he kind of said the same way the planets orbit the sun is exactly what electrons do to the nucleus. And at this time, a guy named James Chadwick had already discovered the neutrons. So you can see these orange neutrons here. Those are what James Chadwick discovered, because he realized the masses, or how much it weighed, did not add up. Now, one thing to note is that the lowest energy level is closest to the nucleus. So this right here would be energy level 1, and then energy level 2, and then if we had another one, it'd be energy level 3. It gets higher and higher the further you move away from the nucleus. And then our most recent theory or model is called the quantum mechanical model, or electron cloud theory. Okay, and it was developed by these scientists called Heisenberg and Schrödinger. And what they said was that electrons travel in clouds. So they don't actually have those specific orbits, but there's a certain area of the electron where you're more likely to find it. So if we look here, we see there's a lot of blue dots near the center. And that's because you're more likely to find electrons really close to the nucleus. The further you get out, the less blue dots you have, and the less likely you are to find an electron in that location. But you don't actually know where an electron is at a particular time, because as soon as you find out where it is, it's already gone. They're moving very quickly and they never stay in the same place. So if we were to look at this as a timeline, we have it from Dalton, and then Thompson discovered the proton discovered the electron with a positive mass. Rutherford discovered the nucleus. Bohr discovered the orbitals, and then we now have the quantum mechanical model with the electrons in an electron cloud and the protons in the center, the protons and neutrons in the center that we call the nucleus. Okay, so we switched over to our note sheet, okay, because we want to take some basic notes about the atom, the particles that make up the atom, and where they're located. So there are three main subatomic particles, okay? The first one we're going to talk about is the proton. Now, the proton has a symbol of P with a plus sign as an exponent, okay? And this is because it has a +1 charge. So that positive symbol, protons are positive, and they are located in the nucleus. Now, a proton has a mass of 1 AMU. An AMU stands for atomic mass unit. Atomic mass unit. So, that's what a proton is. It's in the nucleus, it's positive, it weighs 1 AMU. The next one we want to talk about is the neutron. Oh, let's make sure we spell the neutron correctly. The neutron is neutral, so it has a lowercase n with a 0, meaning that it has no charge because it's neutral. It is also located in the nucleus and weighs 1 AMU, roughly. So a neutron and a proton are about the same weight. Our third particle is an electron. An electron is in a lowercase e with a negative sign because the charge is -1 and it is in the electron cloud. Okay, and it weighs 0 AMU. Now, of course, the electron doesn't actually have 0 weight, but it is so small that we count it as almost 0. It's actually 1 proton weighs the same amount as 1,867 electrons. So when you think about the difference of that, one electron all by itself essentially weighs nothing. So if we look at the way an atom would be labeled, okay, and we follow these instructions, it says draw 5 protons in the nucleus of the atom. So I'm going to draw 5 protons in my atom, okay? It says draw 6 neutrons in the nucleus of the atom. So I'm going to draw 6 neutrons, 1, 2, 3, 4, 5, 6. Notice that I did not put a symbol in the middle of my neutrons because neutrons are neutral. They do not have a charge. But I put a plus sign in my protons because they're positive. It now told me to draw 2 electrons in the first energy level and to label them with their charge. Remember, my first energy level is the energy level closest to my nucleus. So I'm going to draw 2 electrons here. Okay, now I drew them on opposite ends of the atom because electrons are going to repel each other. They do not want to be side by side. They want to spread out. Okay, we're next going to draw 3 electrons in the second energy level. So again, I'm going to put 3 electrons and I'm going to spread them out on that energy level. So now it wants to know what element is represented by the diagram. Well, if I have 5 protons, then I look at my periodic table, and number 5 on the periodic table is boron. So that means this element is boron. Now, if I look at the next part, okay, you said, well, number 5, how did I know that? Okay, the basics of the periodic table, you have this box, okay? And this box tells us several different pieces of information. This number at the top is called my atomic number. The O represents my symbol. Every element has a symbol that has a capital letter, and if there are multiple letters, the remaining letters are lowercase. It has a name, so this one is oxygen, and then we have an atomic mass. Okay, now number 7 says, what does the atomic number represent? Well, the atomic number represents the number of protons, but it also represents the number of electrons because the most atoms are neutral, meaning that they have no charge, so the positive protons and negative electrons have to balance out. Okay? What does the atomic mass represent? Well, the atomic mass is how much something weighs. And if we look at our chart right above, we notice that the protons and the neutrons weigh 1 AMU, but the electrons weigh nothing, which means that the atomic mass is my number of protons plus my number of neutrons. I do not add my electrons in there in order to calculate the mass. So if we want to figure out the number of protons or electrons in it, we would just look at the atomic number. But if we want to figure out the number of neutrons, I need to take my atomic mass and subtract my atomic number to give me my neutrons. Okay, so if we look at our chart below, I'll do the first few and then you can practice the rest on your own. We see that Li, lithium, has an atomic number of 3 and an atomic mass of 7. So my atomic number of 3 tells me that I have 3 protons and 3 electrons. And to determine my neutrons, I'm going to take my mass and subtract my atomic number. So 7 minus 3 gives me 4. If I look at number 2, P for phosphorus, I have an atomic number 15 and an atomic mass of 31. The number 15 tells me that I have 15 protons and 15 electrons. If I take 31 and subtract 15, I can get my number of neutrons. which would be 16 neutrons. So we see that my neutrons are not always equal to my protons.